L'Hopital's rule, part 1. Suppose that as x goes to a, the function g is going to 0, and the function f is going to 0. Then L'Hopital's rule says that the limit of f over g is equal to the limit of f prime over g prime, provided the limit on the right hand exists. This rule also applies if x is going to infinity or approaching from the right or from the left. And let's do an example. The function y equals x minus 2 pi, that approaches 0 as x approaches 2 pi. And y equals sine x, that also approaches 0 as x approaches 2 pi. So in this limit, both the numerator and denominator are going to 0 as x approaches 2 pi. And that gives you an indeterminate form of 0 over 0. And what L'Hopital's rule does is it allows you to handle the situation of 0 over 0. So we've got a situation of 0 over 0, and we're going to use L'Hopital's rule in order to find the limit. Watch what happens. Well, L'Hopital's rule says that I take the derivative of the numerator and the derivative of the denominator. When I do that, I get 1 over cosine x. Now notice 1 over cosine x, that can be evaluated directly because at 2 pi, cosine is just equal to 1. So go ahead and just evaluate it directly and you get a limit of 1. So we started with an indeterminate form of 0 over 0, and we used L'Hopital's rule in order to find the limit. Let's do another example. Both of these limits are going to 0 as x approaches 1. And so I've got the indeterminate form of 0 over 0, and I can use L'Hopital's rule. Take the derivative of the numerator and the denominator. And look, now I can find the limit by direct substitution. So by using L'Hopital's rule, I change the limit into something that can be evaluated directly. And so I just go ahead and find that limit. All right, now we just did an example where both limits are going to 0. What if both limits are going to infinity? Well, L'Hopital's rule can be used in that situation as well. And again, this is provided the limit on the right-hand side exists. And also, x can be going to infinity or be approaching from the right or from the left. So let's do an example. Both of these limits are going to infinity. As x gets larger and larger, both of these functions are getting larger without bound. So we can use L'Hopital's rule. In order to find the limit of the quotient, now this quotient I've got infinity over infinity, an indeterminate form. So I take the derivative of the numerator, take the derivative of the denominator, and after I take the derivative of both the numerator and the denominator, I clean it up, and look, again, I've got something I can evaluate. Recall that the radical is going to infinity, but my numerator is just 35 now. So I've got 35 over a number that gets larger and larger and larger, and that tells me that my limit is equal to 0. Now that's the end of part 1. We're going to pick up this conversation in part 2. Take care and have a great day.